Hey everybody, Mr. Judson here. So we're still in section 4 of chapter 1, and we're talking about this thing called the intermediate value theorem. I apologize, this is a little bit blurry. It's not real clear, but it's on page 81 in your book if you want to look at that. And so anyway, I thought we'd do a little bit of reading here today in our calculus class. So the intermediate value theorem says this. It says if f is continuous on the closed interval a to b, and f of a does not equal f of b, and k is any number between f of a and f of b, then there is at least one number c in the interval a to b such that f of c is equal to k. Yeah, is that not obvious? What? What did you just read, Judson? Yeah, you know, this is rough. You read a calculus book and you come across stuff like this and you're like, what in the heck are they trying to say? So we just want to break this down and make sure that we get it. All right, so let's see if we can break this down and make a little bit of sense out of it. All right, I'm gonna draw a picture here. So I've got an xy axis, and I've got some function, starts here and goes down to this point here, and this is the value a, and this is the value b. So the first thing I read here, it says if f is continuous. We now know what continuous means, right? I can draw this curve without picking up my pencil. There's no breaks in it. On the closed interval a to b. So the word closed just means it includes the endpoints a and b. If I was to put parentheses here and open circles, then I would refer to this as the open interval a to b. Okay? So we're including the endpoints. And f of a does not equal f of b. That just means this y value does not equal this y value. Right? F of x means a y value. So yeah, this y value right here is not equal to this y value, so we're okay, we're following the rules. And k is any number between f of a and f of b. So what we want to remember is when you take an x value and you plug it into a function, whatever f of a is, that's your y value. So this value right here is f of a. This value right here is f of b, and so what we're saying is that k is any number between this y value and this y value. All right, let's put it right there. Okay, k is definitely between f of a and f of b. Then there exists at least one number c in this interval, so there's got to be a number somewhere, such that f of c equals k. So that means I'm going to plug c into this function, and I'm going to get a y value back of k. All right, so if I go straight across to right here, there's a point on the graph, then there's got to be some c value down here that I plugged into the function to get this y value. Right? We're saying f of c equals k. This is a y value, so a y value has to equal a y value. F of c has to equal k. And what they're saying to us is there has to be some number in this interval that when I plug it in, I'm going to get this k value. Well, now when you think about that, you think, well, yeah, that's obvious. If this function is continuous, meaning I've got some kind of a curve that goes from here to here, doesn't matter if I go up first and then way down and then hit here, okay? If k is any number between here, it means there's got to be some number I can plug in to get that k value. That's what they're saying. All right, so let's just read through that one more time so it makes sense to us. If our function f, so this is f of x, if f is continuous, which it is on the closed interval from a to b, And the two y values at those endpoints are not equal to each other, so there's some space in between. And k is somewhere between these two y values. If that's going to happen, the horizontal line has to go somewhere and intersect this graph at a point where its x-coordinate has to be between a and b, no matter what this curve looks like. All right, fine. So now my next thought is, why do I need to know this? You know, this is one of those things that they throw into our calculus book, and it's designed to just get us to think mathematically. I'm not sure I have a good example of where you would ever use this in the real world. Let's look at a couple problems here that they're going to ask us to do on today's assignment. All right, so here's a sample problem. It says in exercises 83 to 86, explain why the function has at least one zero in a given interval. Okay, so in other words, if I graph this thing on the interval from 1 to 2, why is it that there's a 0 for this? Well, let's see. These are both x values. So what I'm going to do is I'm going to figure out what f of 1 is equal to. So if I plug that in, 1 to the 4th is 1. So I get 1/12. Plug a 1 in there, I get -1, and then plus 4. So let's see, those add up to 3, and if I add a 12th, I've got 3 and 1/12. So where is that? It's got to be somewhere right about there, just a little bit higher than 3. All right, let's plug in a 2 and see what happens. So 2 to the 4th power, that's 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 times 1/12, that's 16/12. I'm going to plug a 2 in here and cube it, I get 8, and then plus 4. So what is that? That's going to be, if I reduce this, I get 4/3 minus 4. So let's see, if I take a negative number and I add 1, I get -3. Add another 4th or another 3rd, I get a -2 and 2/3. And you can always pause the video and verify that. You know, if someone's looking at that going, how do you do that? Yeah, it's just, you do numbers for a while, you learn how to do things in your head. But here's the thing. I got a positive value here and a negative value here. So at 2, we're down here at a -2 and 2/3, so somewhere just below that 2 mark. And I've got a function that's continuous. How do I know it's continuous? Well, it's a polynomial. All polynomials are continuous. There's no asymptotes. There's no hole in the graph. It's not a square root function, so that doesn't mess with the domain at all. I just know I need to get from this point to this point. And in doing so, we cross the x-axis, right? So we just showed that there's at least one 0. Now, is it possible this graph comes down and goes like this and back up and then down? Sure, it could do that. Now there's 3 zeros. Is that still at least 1? That's all I have to do. So here's my reason. I need to go back and use the intermediate value theorem as a way to justify this. So what I'm going to do is I'm going to say, since 0 is between this y value and this y value, there must be some number, c, between a and b, where we're crossing that x-axis. So since 0 is between these two y values, 3 and a 12th and negative 2 2/3, then there must be one number, which we're calling C, between 1 and 2, where f of C equals 0. So remember what the question said. The question said to explain why this function has at least one zero. And so we're using this intermediate value theorem as a way to justify that. Okay, 0 is between these two y values. Since 0 is between 3 and a 12th and a negative 2 2/3, okay, this is y equals 0 right here. Since it's between those two numbers, there's got to be some number between 1 and 2 where we cross the x-axis. And that's what we're saying here. Okay, then there must be one number C between 1 and 2 where f of C equals 0. Okay, and when I say f of C equals 0, I'm just saying where you cross the x-axis. It's got to happen. So this is really what they're looking for today is, do we understand the intermediate value theorem well enough that we could write it out for a different problem? And so I think what you guys want to do is with today's work, you just want to try and word things just like this. How do I know this is 0? Well, because 0 is between these two numbers, that means there must be at least one number C in this interval where f of C equals 0. All right, let's try another problem. All right, so we're going to do the same thing for this. We want to explain why this function has at least one 0 in this given interval. Okay, so how do I know this function has a 0 in the interval 0 to 1? You guys go ahead and try it. All right, I'm just going to do the same thing. I'm going to plug those two. This is an interval, so these are both x values. So h of 0, if I plug that in, I've got 1 plus 0, and then minus 3 tangent of 0. So you can just punch that in the calculator if you want to see what it's equal to. Or we can remember that on the unit circle, this is the point 1 comma 0. If you're going to do the tangent, you're doing sine divided by cosine, so 0 divided by 1 is 0. Times a negative 3, that's 0, and so what I get is just 1. So there's my first point, 0 comma 1. And then if I do h of 1, I've got 1 plus 1 minus 3 times the tangent of 1, and that's 1 radian, okay? So this is not something that I can easily do in my head. I know it's 2 minus whatever that is. So let's go to a calculator real quick and figure it out. All right, so I want 2 minus 3 tangent 1. All right, so I've got 2 minus 3 tangent 1. And there's what I get, a negative 2.672. So I got the point 1 comma negative 2.672. All right, so if I make a graph here real quick, we're on the interval from 0 to 1, so that's 1. I've got this point, 0 comma 1, which would be right there. At 1, we're down at negative 2.7-ish, so somewhere right there. And this function is continuous, so they're asking us to show or verify that there is a 0. Well, if it's continuous and it's a function, that means that as long as 0 falls between these two numbers, which it does, So we're going to write that down. Since 0 is between 1 and a negative 2.672, then there must be a C value between 0 and 1 where this function crosses the x-axis. There must be a C value between 0 and 1 where f of c equals 0. And that's what they're asking us to show. And so we've done that. All right, let's try another one. All right, so let's look at one more problem here. Using the intermediate value theorem in these next set of exercises, verify that the intermediate value theorem applies to the indicated interval and find the value of c guaranteed by the theorem. Okay, so now instead of saying, show me that there's a 0, it's saying, show me that you cross the line y equals 11. So when I plug these numbers in, I should get one number above 11 and one number below 11. Okay? But they're adding one more piece. They're saying, find the value of c where you hit 11. I'm going to let you guys think about that for a minute. Go ahead and try it. All right, so we're going to do the same thing we did on the previous problem. Let me just slide this up. First of all, I have to show that 11 is between f of 0 and f of 5. So what is f of 0? Well, if I plug it in, I get 0 plus 0 minus 1. There it is. What's f of 5? So when I plug that in, I get 25 plus 5 minus 1. That's going to be 29. So since 11 is between 29 and negative 1, then there's got to be some c value somewhere in this interval where f of c equals 11. And so now that's the question we have to answer is, where is that value? Okay, well, here's my function f of x squared plus x minus 1. I want to know, where does that equal 11? And I better get an answer inside this interval, because if I don't, then this intermediate value theorem isn't really true. So I'll set this equal to 0. I'll bring the 11 over and subtract it. Minus 12 equals 0. I then have to factor this, so I've got x times x, two numbers you multiply to get 12 and subtract to get 1. It's got to be a positive 4 and a negative 3. So that means x equals either negative 4 or positive 3. And remember what we said is there's at least one value in the interval where this function is equal to 11. So this is not in the interval, right? So we need to throw this one out, and that means that our c value is 3. There it is. We've used the intermediate value theorem to verify that there is a c value in this interval where this function equals 11. And remember, when you do this, your k value has to be between f of a and f of b. This is the k value, 11. F of a was negative 1, f of b was 29. If this number doesn't fall between these two, then at that point we stop and we say the intermediate value theorem does not apply. Okay, since 11 is between those numbers, we can move forward and say, okay, where does that function actually equal 11? And we're going to get an answer that has to be somewhere between 0 and 5. All right, that's it. That's what we have for today. It's kind of a shorter assignment or a shorter idea, but let me get you this assignment and you guys. All right, so we've now entered week 6. This is Monday's assignment, so page 84, 85. We're going to do 84 to 86, 96, 97, and 99. All right, there it is, you guys. That's all we have for today. See you on Wednesday. Stay safe.